Hello and welcome to Celette Cameleon complete video tutorial. In this video series, we will review all the features of the Cameleon Universal Jig System and give you tips to make the most accurate repair jobs using this tool. For more than 70 years, Celette dedicated jigs allow technicians to perform the most accurate and precise structural body repairs. However, to keep up with the rapid development of new car platforms, Celette launched Cameleon, the only universal vehicle jig system on the market. The combination of software, adjustable fixtures, and the most complete car database to date allows you to repair all types of vehicle such as unibody, chassis, and light commercial. Hello and welcome to Cameleon Complete Tutorial video number 2, Software Overview and Simple Bench Setup. In this video, we will assume that you already have access to the Cameleon software. If you need help to create an account and register your Cameleon equipment, please watch video number 1, Getting Started with Celette Web Tools. In this video, we will have an overview of the Cameleon software, how to load a car, prepare your setup, and bench a car on 6 vertical jigs. We'll show you how to bench this car, an Audi A3 Sportback Quattro. To get started, we need to go on the website. So let's go to app.celette.com. And we can log in using the email and password we set up in the first video. Now let's head to Cameleon. You have a shortcut over here, or you can access it through the menu. To get started with Cameleon, we first need to choose the car we are working with. Let's click on this button to search for a car. And here you have 3 search modes. You have the quick search, when you can use the search bar to search for car brand, model or year. You have the search by make, where you will be guided to choose the car make, model version and datasheet version. And a search by year, where you will be guided through the year of the car, make of the car, model and datasheet version. Let's try the quick search first. So here we will work with an Audi A3 from 2012, and the car we're interested in is an 8P Sportback Quattro. This is our car. There is 2 datasheet versions for this car. We can pick any of these. We can refine our search using the filters. The make of the car is Audi, the model is A3, and datasheet version is 8P Sportback Quattro. And here we see only the 2 datasheets corresponding to this car, and we can click on a datasheet to load it. Next, we need to choose the mode in which we will bench the car. First, we have the diag mode, for a complete car that we bench for diagnosis. Next, we have WE mode for a complete car, but we remove some bolts from the car and replace them with Celette bolts attached to the Cameleon jig. Then we have WO mode for repairs, where we need to remove some mechanical parts from the car, such as wheel, exhaust pipe, or suspension system. Next, we have mix mode, where we need to take out mechanical parts only in the rear side of the car or the front side of the car. We are working with a body in white here, so let's take the mechanical out mode. And we have already a first configuration loaded on the bench. If you want to show more points than the 6 default one, you can open the points window and activate points one by one. For example, let's show this point in the front, and you can see the new tower appearing here. To hide it, we can click again on this point. You can also activate group of points at the same time. Let's hide the vertical jigs. We don't have anything left. If we click again, we will show all the vertical jigs available. Let's now activate the angle jigs. And we now have the maximum amount of points available in this configuration. If we want to show another point, for example, point number 26, right now we cannot, because there is another jig too close to this one. Maybe it's the point number 18 or number 12. Let's try to hide point number 12 and show point number 26. It's still not possible, so we probably need to remove point 18 as well. And we can now activate point 26. Let's go back to the default configuration with the 6 first jigs using this button. Let's now take a look at the settings window. Here you can choose what bench you are using. If you have a longer car, you may need a large bench or an XL bench. You can choose it here. Let's go back to the regular bench. Likewise, you can change the kind of crossmember you will be using. So you can choose between the regular crossmember and the special crossmember. And let's go back to the original ones. If you need to inspect your jigs in 3D, you can navigate the view using the mouse. So you can use the left mouse button to move around, the right mouse button to rotate, and the scroll wheel to zoom in and zoom out. You can also double click with the left mouse button to reset to the original camera. We also have other modes of viewing. We have a top view, where you can also use the left mouse button to pan, the right click to rotate, the mouse wheel to zoom in, zoom out, and left double click to reset to the default settings. We also have cameras on the left, on the right, on the front, and the rear of the bench, with exactly the same control, except that no rotation on this one. Let's go back to perspective view. The offset bar here is used if you need to move the car relative to the bench. So for example, if you have some point too far out in the front or the rear of the car, you can change the x-axis to move the whole car down to a relative to the bench. So let's change minus 244 by minus 100. And we see that the setup is the same, but all the jigs have moved backward a little bit. Same for the height. If you don't have enough high tower, or for any reason you want the car to be lower relative to the bench, you can change the height. And we see that all the jigs have lowered a little bit. Let's get back to the default configuration and start inspecting those jigs. So if you click on the tower, you have all the info here to build a jig. If the point picture is not showing up, you can click on this button to toggle it and check out what point you're working with, more precisely over here. And on this window, you have all the info you need to build a jig. Position of the cross member on a tower, sliding block, sliders value, tower, piston, plate, height adapter, socket, and height adapter offset. We can also have all this information available in a drawing you can print and have in the shop. In this drawing, we have all the info we need to build this configuration. For each tower, we have a box corresponding with the info to build a specific tower. So we are working with point number 27, and we have all the info here. Position on the bench, orientation of the tower, type of sliding block, slider's value, tower, piston, plate, height adapter, socket, and height offset settings. At the bottom of the drawing, we also have a list of all the parts we will need to build this configuration: cross members, towers, pistons, plates, height adapter, and sockets. Some precision about the socket types. The green socket is a UF socket. It is a female socket that goes over the bolts of mechanical parts, mostly found in diag mode. The yellow socket is a UV socket, male socket with a bolt to be inserted in threaded holes once the original bolt from the car has been removed, usually found in WO mode. The blue socket is a UM socket, a male socket that goes into the hole of the car without thread. Can be found in any mode. If for some reason, when lowering the car, some jigs are hitting the body of the car, you can use the controls in the jig panel in order to adjust the jig. For example, in this point number 13 in diag mode, this jig might not reach the point because it would have to go through the suspension system. To resolve this issue, we can try to use a longer height adapter so the jig can fit into the hole in the suspension system. Other available control for the jig is rotating the plate, choosing a higher or lower tower, changing the slider's value to move the tower a little bit, or move the position of the tower on the bench to move it further. Once you're happy with your configuration, you can click on this button to save it and access it later. Configuration has been saved. Let's try to load it back. We can find it over here. Now that we've got the desired configuration in the software, we can start assembling the bench. First thing we have to do is to place the cross members on the bench. First, we're going to place the two front cross members on the front edge of the bench. Next, we are going to place the rear cross member at number 25 on the bench, as highlighted here in the software, or here in the drawing. Note that we are using a regular cross member instead of the rear cross member because we will be adding more jig to this configuration in a following video. Let's now assemble the jigs. We usually build the jigs in order, starting in the front and ending in the rear. We'll start with point number 11 and assemble it from bottom to top. First thing, we have to spot its location on the bench. It will go at position 8 in length and -4 in width, as indicated in the jig window. You can find these positions here in the 3D view, 8 -4, and here in the drawing, 8 -4. In this position, we place a sliding block type L to go on the left side of the bench. with the arrow pointing forward. We tighten it down. We input the values in the sliders. For the length slider in yellow, we input 66 mm, and for the width slider in green, 62 mm. We tighten it down. Repeat this process for all other jigs. On top of the sliding block, we place tower MZ260, facing toward the rear of the bench, as indicated in the 3D view by this yellow notch, or in the drawing by this triangle. Bolt down the tower. We recommend to leave the bolts a bit loose, so it's easier to fit the jig inside the hole when lowering the car on the bench. And we do the same for the remaining jigs. Next, we are going to assemble the piston, plate, height adapter and socket. We'll be using a piston P160. On top of it, we bolt a plate UP004. On the plate, we screw a height adapter AD05. On top of the height adapter, we screw a socket UV13 with a height offset of 1.9 mm that you adjust using this ruler. We will also need an HM screw of diameter 12 and pitch 150, along with a screw stopper VB12.150. We can now place the piston inside the tower, following the orientation you see in the 3D view or in the drawing. For this jig, we'll select the pin in the second hole from the top in the tower, as indicated by this -2 after the tower name, and in the hole D in the piston, as indicated by the -D after the piston name. We can now repeat the same process for all of the pistons. And finally, we are ready to bench the car. To facilitate fitting the jigs in the hole when lowering the car, we recommend using only 4 jigs and taking out the pins of the remaining jigs. We will slide them up later into their holes. Among our 4 initial jigs, you can already attach loosely to the car the one with UV socket before lowering it onto the bench. We can now lower the car until it's hovering just above the jigs. Adjust the bench so the jigs are in front of the holes. Continue lowering the car just enough so you can tighten the bolt of the jigs and the towers. Tighten the bolts of these 4 towers. Finish lowering the car and let it rest completely on those 4 jigs. Then slide up the pistons of the remaining jigs, fit the socket into the holes, and secure them with the pins. For this jig, we have an example where the screw doesn't fit into the hole because the car has been damaged. In a following video, we'll show you what to do when you encounter this situation and how you can use your Cameleon kit as a measurement system in order to assess the damage. We had an overview of the Cameleon software, and we saw how to bench a car on vertical jigs. You should now understand the basics of how to use the Cameleon kit and the Cameleon software. Cameleon Complete Tutorial video number 3, Angle Jig Setup. In this video, we will show you how to build 2 kinds of horizontal jig, double horizontal jig with the FB2 plate, single horizontal jig with the FB1 plate, and 2 kinds of jigs at an angle, using rotatory body and axe 60, or cube 60 and ANC 90. First thing, let's head to Cameleon. And the car we used last time is already loaded with the configuration we saved. Let's go to the points window to add some angle jigs. First, let's add a FB2 double jig in the front. So this jig will cover points number 3 and number 1 in the front longitudinal member. So we can toggle either one of those, 1 or 3. And we have the jig appearing here, ready to use for the 2 points. If the jig only shows with 1 point, you can click on this button, toggle double jig, to show the second point. In this tower configuration, we might have some trouble to put the screw in because it will hit on the piston. So we recommend to change the body type for this tower and use a body A instead of a body B. So now we have clearance to put the 2 screws in the holes. Next, we will add another horizontal jig in the back, but this one in the single form, not in the double. So let's toggle point number 51. And you can see it appearing here. In the current configuration, the car might have some flex in the rear. So in order to use point 51 accurately, we need to add more vertical jigs to support the rear of the car. Angle jigs are not meant to be fixation points, only vertical jigs are. Let's go ahead and add points 45 and 46 to the configuration. And now the car is properly supported in the front and in the rear. Next, we will add 2 points at an angle. We'll add point number 30. By default, this point loads with a rotatory body and axe 60. But for this point, we will switch for a ANC 90 to have an example of a jig with a cube and ANC 90. The software gives us a configuration with a TV plate, but I think we can find a configuration without. So let's try to play around and get rid of it. If we move the sliding block, now we have a simpler configuration without the TV plate. Let's add a second point on this cross member. Toggle point 29. For this jig, we will keep the rotatory body and axe 60. We now have a configuration with every kind of angle jigs. So let's start assembling it. First, let's push the car back into the shop so we can add the new jigs directly on the car. Let's build a double horizontal jig. We will assemble it completely and then add it to the bench. For this jig, we need a tower MZ260 and a piston P310. For the piston head, we will need a rotatory body type A, that we can already assemble with the piston and the tower. We bolt the body onto the piston. Next, we will need an FB2 plate with an axe A. And 2 pairs of ADZ plus HVB sockets to hold the screws in place. Now we can insert the axe A into the body A. We bolt it down. Bolt the FB2 plate onto the axe A. And attach the 2 ADZ plus HVB onto the FB2 plate. We can now adjust the jig settings. Let's slide a pin in the first hole from the top in the tower and in the hole M in the piston. For the body A, we input an angle of -40. For the axe A, we input an angle of 75.2. We adjust the bottom point at 68.2 millimeters. And the top point at 14.4 millimeters. Let's now add the jig to the bench. This jig is using a TV plate. So let's add it to the bench. Place the sliding block. Adjust the slider's value. Bolt the tower onto the sliding block. And we can now bolt the screw and screw stopper HM and VB into the holes. Let's now add the 2 additional vertical jigs. 0.45, sliding block, tower, and socket. 0.46, sliding block, tower, and socket. Let's build a single horizontal jig, jig number 51. We will need a tower MZ260, a piston P220, for the piston head, we use a rotatory body type A, that we can already assemble with the piston and the tower. We bolt the body onto the piston. Next, we use an FB1 plate and an axe A. And to secure the bolt, we use a ADZ and HVB socket. Place the axe A into the body A. Bolt them together. Bolt the FB1 plate onto the axe A, making sure that the FB1 points toward the letter A on the axe A, and secure the ADZ and HVB onto the FB1 plate. Now let's adjust the jig. We slide the pin in the second hole from the top in the tower and in the hole G in the piston. For the rotatory body, we input an angle of -40. For the axe A, we input an angle of 0. And the ADZ offset on the FB1 plate is 7.5 millimeters. We can now add this tower to the configuration. First, let's place the crossmember. Then place and adjust the sliding block. And bolt the tower on top of the sliding block. And we can now bolt the screw and screw stopper HM and VB into the hole. Let's build an angle jig with rotatory body and axe 60. We will use a tower MZ140 and a piston P100. For the tower head, we use a rotatory body type B. We bolt the body B to the piston. For the angle, we use a axe 60 type B. A height adapter AD05. A socket UV11 and a VB screw stopper. Let's finish to build the jig. We insert the axe 60 into the body B. Bolt them together. We bolt the height adapter onto the axe 60 from the side where the B is written. And finally, we add the UV socket. Let's now adjust the jig. For the body B, we input an angle of 0. For the Axe 60 Type B, we input an angle of 4.2. And for the height adapter, an offset of 6.5 mm. We can now place the jig onto the bench. First, add the cross member. Place and adjust the sliding block. Place the tower. Slide the piston up and put the pin in the first hole from the top in the tower and the C hole in the piston. You can now use the screw and screw stopper HM and VB to bolt the jig to the car. Let's build an angle jig with a Cube 60 and ANC 90. For this jig, we will need a tower MZ80, a piston P100, and for the piston head, a Cube 60 and ANC 90. Let's bolt the cube onto the piston. And the ANC 90 onto the cube, making sure to be on the right side of the cube. Next, we add a height adapter AD05, a socket UV11, and a VB screw stopper. We input an angle of -16.8 in the ANC 90. And a height offset of 14 mm. We can now add this jig to the bench. Place and adjust the sliding block. Place the tower. And slide a pin in the first hole from the top in the tower and the B hole in the piston. Finally, you can use the HM screw and VB screw stopper to bolt the jig in place. We've seen how to operate 4 kinds of angle jigs. You should now be able to use FB2 double horizontal jig, FB1 single horizontal jig, Axe 60 angle jig, and ANC 90 angle jig. Cameleon complete tutorial video number 4, Side Jig Assembly. In this video, we are going to learn how to assemble the Cameleon side jigs in order to repair pillar A, pillar B, and pillar C on the side of a car. First thing, let's head to Cameleon. And the car we used last time is already loaded with the configuration we saved. For this configuration, we are going to keep the 6 default jigs and add the side gantry. Let's head to the point window and add the point 59 for A pillar, 63 for B pillar, and 65 for C-pillar on the left side of the car. We now have the side gantry and the 3 side jigs in the configuration. You can click on the side gantry to have information on how to build it, and also click on individual jig to have the info to build them. First, we have a drawing with all the parts we need to use, and at the bottom we have the adjustment values for all the joints. A pillar and B pillar are similar, but the C pillar is built using different parts. Let's start by assembling the side gantry. First, we will place the 2 cross members for the side gantry. The front cross member is going on position 14 on the bench, and the rear cross member is going on position 28 on the bench. We need to use the special extension for side gantry. On top of the extension, we place 2 towers MZ260 pointing forward. In the towers, we insert the T-shaped pistons for side jigs, using hole number 4 from the top on the piston and hole number 2 from the top in the tower. We can now place the rail for the side gantry on the piston, making sure that the number -7 on the rail is right above the front piston. Now, let's assemble the jig for the A-pillar. There is 4 joints we need to build in order. Let's begin with joint number 1. We'll be using a plate SP050 with an arm F. We enter a setting of 88.8 mm in the slider value. With an angle of 2.2. The second joint is between the arm F and an arm B. We enter a slider value of 121.6 mm with an angle of -0.5. Next, we are going to assemble the bottom point. This one uses a slider SF150. With a slider value of 97.9 mm. And a socket SVB09. Next, we are going to assemble the top point. First, we will adjust the slider on the arm B with a value of 270.9 mm. Next, we are going to use a slider SF150. With a slider value of 79.3 millimeters. And to finish, we use a socket SD 20.09 with an adjust value of 8.2 millimeters. We can now place the jig on the rail at position -7 and insert the two HM8 screws into the holes. The B pillar is assembled in the same way as the A pillar, so we will not go into detail about it, and we can add it already to the bench. Let's now assemble the C pillar. For the first join, we will use a plate SP050 and an arm D. We input a slider value of 150.5 millimeters, and we will adjust the angle later as it may prevent to insert the screw into the hole. For the second join, we attach an arm F to the arm D. With a slider value of 125.6 millimeters. And for the third join, we attach a slider SF200 to the arm F. With a slider value of 33.9 millimeters. And an angle of -2.7. At the end of the SF slider, we attach a VP plate that will hold the screw in place. We can now place the C pillar on the rail at position 9. Secure it with the screws. And we can now adjust the angle on the arm D at -13.2. And we can now insert the screw into the hole. We've seen how to assemble the side jigs for pillar A, B, and C. You should now be ready to use them in your repair process. Cameleon complete tutorial video number 5. Diagnosis report for damaged vehicle. In this video, we are going to show you what to do when you encounter a damage point on a car and how to use your Cameleon kit as a measurement system in order to assess the damage. In a previous video, we built a jig for the front subframe attachment on this car, and we noticed that it would not fit into the hole. This means that the right front longitudinal member has been bent. We will now show you how to make a report of the damage. First, we need to adjust the jig until the screw fits in the hole in the damaged position. In order to do this, we need to untighten the sliding block and lower the height adapter. We can now slide up the piston and secure it with the pin without hitting the car body. Adjust the sliding block, put the screw in, and screw the socket back up until it's tight against the car body. We can now read the values of the height adapter and slider's value in order to use them for the report. If you notice that other points are damaged, you can repeat the same process for them and include them in the report as well. Note that, for now, the diagnosis report is only available for vertical points. Let's now open the software and create the report. First, let's open Cameleon. And our saved configuration is already in the software. Let's go to Report. And any information you enter here will appear on the report. You can enter the survey type. This one is a diagnostic report. You can enter the date, write some notes, have some details about the technician. Here, you need to enter an ID for the report. And here you can give some information about the insurance. We don't have any, so let's click Next. Now give some information about the vehicle. Some information is already filled in according to the car loaded in the software. We need to enter a VIN number. You can also enter the year, the license plate, and the mileage of the car. Let's click on Next. Here you can give some information about the customer. Let's click on Next. And finally, here is the place where you enter information about the points. So we are working with point number 12. In these boxes, we need to enter the values we read on the sliding block and the height adapter. In the length value, we read 68 millimeters. In the width value, we read 64 millimeters. And on the Z offset, we read 4 millimeters. Let's choose a picture to upload for this point. Here you can view the picture you choose. And with this button you can discard it. If you have measured any other point, you can do the same for them to add other measures. We didn't measure any other point, so we can just save the report. And here we can open the report. We can see all the details we entered about the body shop, about the customer, about the insurance, the job detail, the vehicle. And here is the report about the points. We can see the details we enter for the point number 12. It has deviated 2 mm in length, 2 mm in width, and 2 mm in height. You can see this deviation with the small arrows on the drawing here. And at the bottom, we can see the pictures we entered for this point. We've seen what to do when you encounter a damage point when benching a car on a Cameleon, and you have now learned how to use your Cameleon kit as a measurement system in order to assess the damage.